We are now going to solve applied problems using quadratic equations. In this particular problem, we're talking about skydivers. And skydivers are in a free fall from the time they jump out of a plane until they open their parachutes. A skydiver jumps from 5,000 feet. The diver's height, h, above ground, t seconds after the jump, is described by the equation h equals minus 16t squared plus 5,000. Find the time during which the diver is in free fall, assuming that the parachute opens at 1,000 feet. So the key here is to notice that this is a translation problem, but despite being a translation problem, we are given the equation. And the 5,000 comes from this starting point, and the minus 16 comes from gravity. This represents gravity in the equation. It was pulling our height back down towards 0. And so what we want to know is when is the diver at 5,000 feet, because that's when he starts his free fall, and when is the diver at 1,000 feet. In other words, how long does it take him to fall from 5,000 to 1,000 feet? So the way that we're going to do this is we're going to set our heights equal to these one at a time. So we're going to let 5,000 equal minus 16t squared plus 5,000. Well, this one's real easy. When we subtract the 5,000 from both sides, we get 0 equals minus 16t squared. Divide by negative 16. 0 equals t squared. Or, using the square root property, when we take the square root of both sides and put the plus or minus in front of it, we get t equals 0. So that one's pretty straightforward. At time equals 0, we are starting our free fall, which is why the model is set up the way it is. The other one's a little bit harder. When does 1,000 equal minus 16t squared plus 5,000? Well, this is going to take a little more work. We'll subtract 5,000. Which gives 4,000 equals minus 16t squared, minus 4,000. I'm going to divide by negative 16, but I'm going to leave it in this form for just a moment. So we get 4,000 over 16 equals t squared. Well, 16 goes into 4,000. Let's check that out. 250 times. So 250 equals t squared. Use our square root property to give us t equals plus or minus the square root of 250. Well, 250 is 25 and 10, so that's really 5 root 10 equals t, plus or minus. But we aren't in free fall before we jump out of the plane. This is where that common sense comes in that I've referenced a few times. We need to make sure that we only allow this to be the positive one. So 5 square roots of 10 equals t. So we're in free fall from 0 to 5 square roots of 10. That's our mathematical answer. But if we want to know what that is, we just raise this to the 1/2 power, take the square root of 250, and that's 15.811 seconds. So from 0 to 15.811 seconds is another way of writing our answer. I'm going to put a parenthesis because it's approximately that, but we're rounding it so we're not quite sure. And so that's how we can use our quadratics to find answers to applied problems.